All right, we're going to do a little bit of a review on everything we've done here in analytical trigonometry. And the first thing I really want to review are some of those identities. So let's start with one that we haven't done too much with. So let's start with, so example number one, I'm going to say tangent of 105 degrees. And we need to figure out what that's equal to. So remember, 105 degrees is not really a nice angle on my unit circle. I need to be able to evaluate this using my unit circle if possible. So I'm going to break that 105 degree into two angles I actually know something. And this can vary, right? You can use two different angles than I do. So I'm just going to use 150 degrees minus 45 degrees. And that would give me 105 degrees. And so now I need to remember my tangent. Difference of two angles for tangent would be the tangent of the first angle, so tangent of 150 degrees. When you have a minus here, you're going to keep a minus here, so minus the tangent of my second angle, which is 45 degrees. All over 1, and when I have a minus here, down here I'm going to have an addition, so 1 plus, and now it's going to be the product of those two tangents, right? So the tangent of 150 degree times the tangent of 45 degrees. And now it's just a matter of using your unit circle to evaluate that, right? So the tangent of 45 degrees is nice and easy, but we might need to recall what the tangent of 150 degrees is. So let's do that here on the side. So what is the tangent of 150 degrees? Well, it will be equal to 1/2. Probably need to remember where 150 is, don't we? So this will be 180, right? So it'll be just short of that, so we'll be right there, right? So this will be 5 pi over 6. And at 5 pi over 6, this will be root 3 over 2 negative, and the y value will be a positive 1/2, right? So the tangent is sine over cosine, so the y over the x, so 1/2 over a negative root 3 over 2. And when you simplify that, you're going to get negative 1 over a root 3, and then you rationalize the denominator by multiplying top and bottom by a root 3, and that will give you negative root 3 over 3. So that's my tangent of 150, and I'm going to need it here. So this was really just kind of like a let's get ready. And we know that tangent of 45, this is a nice and easy one. This is just going to be 1 because it's root 2 over 2 divided by root 2 over 2, which is equal to just 1. All right, so let's plug in all we know. I'm going to change color a little bit so we kind of keep track of what I'm saying. So now I'm going back to my identity here. And tangent of 150, we just said, was equal to negative root 3 over 3, and then minus tangent of 45, we said was just 1, so minus 1 over 1 plus, and now I need the product of those two, so the product of negative root 3 over 3 times 1 equals, and you're going to have to keep working that, but you guys hopefully know how to deal with fractions. So I'm going to multiply, let's just do negative square root of 3 over 3 minus 3 over 3 all over, that's just going to be a 1, so I'm going to have a 3 over 3 minus a square root of 3 over 3. And all of those 3 cancel, right? Because I could multiply all the way through by a 3/3, right? And so all of those denominators will cancel. So I'm going to end up with negative square root of 3 minus 3 over 3 minus square root of 3. And at this point, I need to rationalize my denominator, because if you pay attention here, we still have a square root in the denominator, which we don't want. So we're going to multiply by the conjugate of that denominator. So here and there, the conjugate of that denominator will be 3 plus root 3, 3 plus root 3, and that will simplify. So those two are just going to end up being negative 3 root 3, and then you're going to have a 3 times a negative 3 will be negative 9, and then we're going to have negative square root of 3 times positive square root of 3, which will be negative 3, and then negative root 3, negative 3 root 3, and all of that, two conjugates together, right? So that would just be the first term squared. Oops, let's just go ahead and square that, right? You guys can handle that. So 3 times 3 would be 9 minus the second term squared, and when I square the square root of 3, that will just be 3. Okay, so all of that is going to go to negative 3 square root of 3 minus 3 square root of 3 will be negative 6 square root of 3, minus negative 9 minus 3 will be 12, all over 9 minus 3, which will be 6. And now we can go further, right, because we can simplify this. So negative 6 over 6 is negative 1, so that's just negative root 3. And negative 12 divided by 6 is just minus 2, and that will be the simplified version of this. Okay, so that's for tangent with, sum or subtraction formula for the tangent, which we haven't really done much of. Okay, so now let's find another example. I don't think we need... Okay, let's look at one of those. If I said, so next example, if I said we're going to have the sine alpha plus beta is equal to, so here I'm just recalling what is that formula, right? So it's sine of the first angle times cosine of the second angle, and we have a plus here, so with sine we don't change anything, right? So it stays plus. It's going to be cosine of first angle times sine of second angle. Okay, that's just the formula. And so we need to find sine alpha plus beta, and we also want to find cosine of 2 beta given sine alpha is equal to 4/5, and we're told that this will be between 0 and pi over 2, so alpha is between 0 and pi over 2, and given as well that sine beta is equal to 5/13, and beta, we're told, is going to lie between pi over 2 and pi. So remember, that's just telling us that alpha is in quadrant 1 and beta is going to be in quadrant 2. That's what that tells us. So I'm going to go ahead and kind of already do a sketch on that. So I'm going to have my alpha in quadrant 1. So here is my angle alpha. And I'm told that sine alpha is 4/5. So that will be 4. So opposite over hypotenuse. And that also tells me, using the Pythagorean theorem, I already know this side has to be 3. And now I'm going to switch to my beta, and beta I'm told is in quadrant 2. So this will be here. This is my angle beta. And we're told that sine beta is 5/13, so opposite over hypotenuse. And if this is 5/13, we know this side is to be 12, but now you have to be very careful. This is in quadrant 2, therefore those x values are negative. So this should be a negative 12. So don't mess up on that. Don't miss that negative. And now it's just a matter of putting all of that in this formula, right? So we need to find sine alpha of beta. So sine alpha beta is equal to sine alpha. I'm not going to rewrite it because it's just above, right? We already have that above here. So that will just be, so the sine alpha is in quadrant 1 and the sine is 4/5. That was given to us, right? We already knew that that was given. So this is just going to be 4/5 times cosine beta, and the cosine beta is going to be in quadrant 2. Cosine will be negative 12/13. So multiply that by negative 12/13. And then plus cosine alpha, so I'm going back to quadrant 1, cosine alpha will be 3/5 times the sine beta, right? And sine beta will be opposite of our hypotenuse is 5/13. And then you're just going to simplify all of that, and that will give you negative 48 plus 15, if I did that correctly just a few minutes ago, over 65, and then that will be negative 33/65. Okay, that's the answer for sine alpha plus beta. Now I still need to find, remember we also had to find what cosine of 2 beta was, right? So let's do that now. So cosine of 2 beta. So we need to remember the double angle for cosine. And remember, we have 3 different versions. So I'm just going to use one of them. And I'm going to say, okay, well, cosine squared of beta minus sine squared of beta. That's one of them, right? So I'm just going to use that because I already know the cosine of beta and the sine of beta, right? So equals cosine beta is negative 12/13 squared, right? Because this is squared minus, and the sine beta is just given to, no, sine beta wasn't, yes, sine beta was given to us as 5/13. And again, this is squared, right? So we're squaring it. And now you're just going to put all of those numbers in your calculator, or you can do them in your head if you want to. And when I did that a few minutes ago, I had 119 in the numerator over 169, and that doesn't simplify, so that will be my answer. Okay, so that's for a few of those. Now let's go to some inverse. Okay, so number 3, we're going to find, maybe do a cosine inverse of a cosine of negative pi/4. Okay, so we have to think about the cosine is an even function, right? And so, and we remember that cosine inverse is going to be restricted to quadrant 1 and 2. And this negative pi/4 is not in quadrant 1 and 2. This negative 4 will be down there, right? And we can't go there. But think about it this way. And negative pi/4 will be right there. And because cosine is an even function, this y value will be the same y value as 4 pi over 4. So I'm going to rewrite that and say, oh, actually, I think I want the cosine inverse of the cosine of pi over 4 because that will be the same thing, right? Because of that nature of cosine, that's an even function. And now, because those two are directly inverse of each other, right? This is not like I had a sine inverse of a cosine. This is really the cosine inverse of the cosine. Those are inverse of each other, therefore they're undoing each other, they're canceling each other out. So we just have to worry, is this going to be in quadrant 1 or 2? Because that's what I need for a cosine inverse. And it will be actually pi over 4 will be right there, right? In quadrant 1, so we're good to go. We can say those two just cancel each other, and that's just going to be pi over 4. Okay. Now, sometimes it doesn't work just nicely like that. Sometimes we don't have just a function with its own inverse. For example, if I had tangent of sine inverse of 1 over 3, well, now that's a little bit trickier because I need a right triangle. Those two are not just inverse of each other. And I'm going to have that in quadrant 1. And I'm going to say, okay, this is going to be 1 over 3, the sine of 1 over 3, so that would be opposite over hypotenuse, which tells me that down here I would have the square root of 3 squared plus 1 squared, which is really the square root of 10. Oh, no, 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 no. Oh, no, 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 no. Did you catch it? I should have a subtraction there. I was thinking that's not right. And it's not. This is the hypotenuse, right? So it's 9 squared minus the leg squared. So it's 9 minus 1, which is square root of 8. Now that simplifies. That becomes a 2 square root of 2. Okay. So this side right there will be a 2 root 2. Everything is positive. I'm in quadrant 1 here. So I'm going to say, okay, this is my angle theta. So really what I'm looking at is equal to tangent of theta. And I have my theta right there. I have my triangle set up. Tangent is opposite over adjacent. So that would just be 1 over 2 root 2. And then I rationalize the denominator by multiplying top and bottom by that square root of 2. So I have a square root of 2 of 4. All right. Let's see, what else could I show you? Verifying an identity. Yeah, I knew there was something I wanted to talk to you about. We haven't really done much of those lately. So if I had to verify, for example, let's do one that's a little bit more involved. Cosine of 3x is equal to 4 cosine cubed x minus 3 cosine x. And what we have to do is verify this identity or prove it. Verify, some people say prove. Prove equality. So we need to prove this is a true equality. Okay? All right. So what we need to do, remember, is we're working with one side of the equal sign and don't touch the other side. So I'm going to work with this side because I know there is a formula, an identity I can use for that. So I'm going to work with that side. I have something to work with. So I can rewrite that as cosine of 2x plus x. Now, why do I do that? Because I don't have an identity for 3x, but I have an identity of cosine for a double angle, and I have an identity for a sum of two angles. So that's why I'm going to use that. Oops, where did you go? Stay here. Okay, now I don't want to touch that right-hand side, so I'm not going to do anything there. Now I'm going to rewrite cosine of 2x plus x. So first of all, let's use colors here. So that cosine of 2x plus x is going to become, so I'm going to split the sum formula, right? So cosine of the first angle times the cosine of the second angle. And cosine, when you have a plus here, it's the opposite. So we have minus here, sine of the first angle times the sine of the second angle equal, and then it's still hopefully equal to that. That's what we're checking, okay? So now we're going to keep working on that. But now I have a cosine of 2x here, and the cosine of 2x I can rewrite as, and we have three different identities we can use here, but I'm just going to use this one, cosine squared of x minus sine squared of x. That is just for this. And now I'm just going to recopy that cosine x down here, minus, and then again, I want to rewrite that sine 2x as 2 sine x cosine x. That's the double angle identity for sine, and then keep that times sine of x here equals, don't touch the other side. And now we're going to distribute, right? Okay, so I'm going to have cosine x times cosine squared x is cosine cubed x. We're making progress to see what we have here. Okay, so we're making progress. Cosine cubed x minus, I have a sine, oops, stay up here. I have a sine squared x times cosine x. And then on this side here, we're just going to multiply. So we have that sine here multiplied with, oh, this is cool. I'm not sure what I just did, but this is cool. Not sure how that happened, but that was cool. Okay, 2 sine x cosine x times sine x will be minus 2 sine x squared cosine x. Oops, what am I doing? Where does my x go? Up in the sky up there. All right, equal, and we are not touching that side. Now we keep looking. So look at what you have now and see if there is anything. And ooh, sure enough, can you see it? Can you spot it? We have a negative sine squared cosine x and a negative 2 sine squared cosine x. Those can be combined, they're like terms. So we're going to end up with minus 3 sine squared x cosine x. And on the other side, we still have that cosine cubed x and then equal. And now when I'm looking at that, and looking at, oh, I lost it, what we wanted up here, I don't want that sine square. See, that sine square has to go because I don't have any sine square in there. So, okay, we're going to rewrite that sine square. And lucky us, there is an identity. There is an identity to rewrite sine square, right? Because we know that sine square is the same thing as 1 minus cosine squared of x. Okay, so I have cosine cubed x minus 3 times that sine squared x, which I rewrote, times cosine x. Okay, and now we're going to simplify here. So I'm going to distribute this 3 and actually even this cosine. Let's do it all at once. So we have cosine cubed x. Okay, so we have a negative 3 and then times that cosine. So that will give me negative 3 cosine x. And then I have a negative 3 times a negative cosine squared will be a positive 3 cosine squared times another cosine will be a positive 3 cosine cubed. of x. And now we're going to see how that simplifies. I have a 3 cosine cubed and a 1 cosine cubed here. So those are like terms, right? These are like terms. So that will be 4 cosine cubed x minus 3 cosine x. And let's check one more time what we needed. And sure enough, we got it. This is equal to what we started with, which was 4 cosine cubed x minus 3 cosine x. And we proved it. Okay, some people put the 3 bar. I like the 3 bar. Some people like the QED better. All right, it doesn't really matter. I like the 3 bars, but it doesn't matter. Okay, that's how we show an identity, right? We're working with one side, and you pick the side where you can spot that there is some kind of identity or formula you can use to re-express that, and then you just keep working and making your way so that you can match the other side. Okay, I think I want to keep it there. This is 26 minutes long already, and I think yes, I think I'm going to leave it here. Should I do? Oh, let's do. Okay, let's do one more. I just changed my mind. I just saw one that we haven't done much of. So let's just do one more tangent. But let's do a tangent of let's just rewrite. What is the formula? Can you just give me the identity for the tangent of an angle divided by 2? So a half angle for a tangent. And do we remember what that would be? So there are also 3 different ones we could use here. So plus or minus the square root of. The half angle of the sine is 1 minus cosine alpha over 2. So, and the half angle for cosine will be 1 plus cosine alpha over 2. And since tangent is sine over cosine, the over 2's and over 2's will cancel. And that will just be 1 minus cosine alpha over 1 plus cosine alpha. So that's one version of it. And then there was another one. And that's if I multiply top and bottom of this here by 1 plus 1 plus cosine alpha. I will then have a square of that down here. And I'm going to end up having equals. So I'm going to not have a square root anymore. So no more plus or minus. Will be just 1 minus cosine alpha over sine alpha. Or if I do it the other way and I use other one, in one case I'm going to multiply top and bottom by the numerator, in the other case by the denominator. So this one would end up being sine alpha over 1 plus cosine alpha. Okay, so those are your 3 formulas for the half angle for the tangent. Okay, that's enough for one video. Goodbye.